Our speaker for this talk is Francisco Donoso, who is currently working at Randori down in Denver. This is a startup. I think you guys started in March, was the beginning of operations. And this is a security company with a nation-state actor focus. And Francisco has been studying the equation group malware since it was originally released by the ShadowBrokers. And today he's going to talk about a component of that toolkit called Killsuit. So take it away.
Thanks. I'm right up against lunch, so I'll get started quickly and make sure you guys can all go eat. As was mentioned, my name is Francisco Donoso, and I'm an all-around security nerd. I run SecOps, DevOps, whatever you want to call it, for a small startup focusing on building a nation-state-like attack platform for non-nation-state customers, corporations that want to test their defenses against what a nation-state would launch at them. I've previously ran an architecture team, a security architecture team. I've been a security engineer. I've responded to breaches kind of all around the world. And I got started doing security analysis, which out of everything I've done was probably my favorite job I've ever had. A little bit of context about what we're talking about today. I'm sure you've heard about it, but we'll be talking about some tools and capabilities that were leaked by the ShadowBrokers in April of last year. So April 2017, there was a leak called Lost in Translation that included quite a bit of tooling and exploits. And when I started looking into this, I was on Twitter, I was on the Twitter frenzy as people were picking apart this leak and trying to understand what was in it in the first few hours that it occurred. And at first I noticed that everybody was focusing on the exploits and the exploitation kit capabilities that it included. But what I was really interested in was, what does a nation-state adversary, a top-tier nation-state adversary do post-breach? Like what is their post-exploitation capabilities? The post-exploitation toolkit is actually leaked as part of the Lost in Translation kit. And it's the large majority of the leak. In addition to some operational notes from an operation against a large Swift processor in the Middle East. So there were operational notes about how the operators actually use these toolkits. There were the exploits that you've all heard about, I'm sure. And there was this post-exploitation toolkit. And personally, I wanted to know more about APT post-exploitation. Most of the time when we as the security community are looking at APT capabilities or nation-state-like capabilities, we're looking at the artifacts that are left behind by the attackers, or some security company has discovered that and reversed it. This was the first time, at least to my knowledge, that we could be the operators and use the tools like the operators could use them. It gave me a little bit more insight into the tradecraft and the type of capabilities that this specific attacker had. I also really want to encourage other people to research and reverse this toolkit. This toolkit and all of the modules within it have been in play for at least 15 years. They've been developing these capabilities for that long. And there's a lot to reverse and to understand. So I'd love to encourage some of you to help me reverse this. And at the time, I also wanted a technical side topic because I was running an architecture team, and my calendar was mostly full of meetings, and I never touched the terminal. So today, we'll cover a little bit about the DanderSpritz post-exploitation toolkit, just a brief overview about it, give you a quick history of some of the frameworks that were included in this leak. We'll talk about how they got to post-exploitation, and then the meat of the talk is all about Killsuit, and we'll talk about what that means. So let's get started with what DanderSpritz is. Well, first of all, DanderSpritz is freaking cool. It's a fully functional post-exploitation kit. And by fully functional, I mean from the moment you land on the box and you have code, to lateral movement, to data exfil, to covering up your tracks, to whatever you want to do, there are capabilities for that in this toolkit. I actually did a talk about DanderSpritz specifically last year at DerbyCon. So if you're interested, take a look at that. And again, help me reverse some more of this stuff. As I mentioned, it's a fully functional post-exploitation framework. The actual framework is written in Java. But it's extremely modular. So the equation group and their tool development teams could plug in a bunch of different functionalities into this overarching framework. And these plugins were written either in Python or before Python, they use custom scripting languages that I'll talk about briefly. DanderSpritz and the post-exploitation toolkit is all designed for stealth. They value operational security above almost everything else. That means that the toolkit has capabilities that enable them to prevent operators or automated processes from getting caught. They have the concept of safety handlers that look at what's deployed on the box, what type of audit logging is enabled, what type of AV systems are installed, and then make configuration changes on what capabilities are available to the operator based on that. As an example, we know that if you do process injection into LSAS, we'll get caught. Don't do that. We'll disable that capability for you. The frameworks, as I mentioned, have been kind of in constant development since at least early 2001. There's actually quite a few different frameworks included in this leak. The first is called EXPANDINGPULLEY, which was the very first version, kind of the predecessor to DanderSpritz. Then we start seeing DanderSpritz, that post-exploitation toolkit and those capabilities, being developed around 2005 with kind of a full rework in 2011. And what we're talking about today, the bulk of the talk is about Killsuit. That started being developed, it seems like, around 2008 and just kind of was in constant development. So quick talk about EXPANDINGPULLEY. As I mentioned, just the predecessor to DanderSpritz, honestly pretty basic as a post-exploitation toolkit kind of CNC server. But what you see here is that the plugin or capability development for EXPANDINGPULLEY was written in this custom scripting language. You can see the extension .eps. That stands for EXPANDINGPULLEY script. Sort of like Perl, but not really, just a custom language that they seem to have developed. EXPANDINGPULLEY, which is again available, was sort of silly. It just launched kind of a Windows command prompt with a little box on the side that told you what things were running on your target machine, so what you were attacking. Then in 2005, we start seeing them shift to the DanderSpritz framework and using DanderSpritz scripts. So they added a few more functionality into the scripting language and called it DanderSpritz scripts and started porting a lot of their tooling from EXPANDINGPULLEY to DanderSpritz. And I just want to thank the Equation Group team for leaving those date and comments up there, along with some compile times. And then around 2011, like I mentioned, they kind of gutted all the custom scripting language and ported that all to Python. My assumption, and it's purely an assumption, is that they wanted to kind of speed up the development, and bringing on someone who knew Python and who could interact with the DanderSpritz framework was much easier than kind of training someone on a custom scripting language that they developed. This is what DanderSpritz looks like as of 2013. The default color scheme is like the Matrix. I'm not sure why they chose that. But it's kind of a GUI CLI mixture of the tool. And as we're going through this presentation, I want you to remember that all of this tooling is from 2013, but it's incredibly effective even against today's defenses. So we don't have access to what they developed after, but the stuff that they had in 2013 is pretty darn impressive. A few terms that I'll be using throughout this presentation that would be helpful. Some of them are industry standard, some of them are not, so I'll just mention them. We have a target, which is really just the machine that I'm attacking, so what I've implanted. An LP stands for listening post, which is just a CNC server. We have a command, which is something that's actually running on the target. So if you see the command parlance in DanderSpritz or Killsuit or something, it's actually running on the target. PSP stands for a personal security product, just an AV system. So there's tools within DanderSpritz to check specific PSPs and their configurations to enable or disable safety handlers. And as I mentioned, safety handlers are intended to prevent an operator or the actual automated tooling that exists within DanderSpritz and Killsuit from messing it up and getting caught. And then the implant is just the malicious code deployed on the target. Brief overview of how we get to post-exploitation using the tools that were leaked in the Lost in Translation leak. The first part is using FuzzBunch, which is, I'm sure some of you have seen, a very Metasploit-like exploitation toolkit where you can touch a machine to determine if it's exploitable to a specific exploit in your repertoire. And if you can exploit it, it'll just suggest the exploit and let you do that. Exploits are things like your Eternal Blues, your Eternal Romance, what you've heard about kind of in the news, and the tools that have been repurposed. Double Pulsar is the in-memory backdoor that's installed by the exploit and listens and waits for commands on what to run. It's a very versatile backdoor. It can run DLLs that can kind of get loaded and injected into memory. It can run shellcode. It can run an exe. Pretty versatile. And what most commonly is loaded via double pulsar is this implant called pedal cheap. So pedal cheap is the actual implant that's responsible for communicating to the listening post. And the listening post is actually DanderSpritz. So DanderSpritz is the command and control server. It's what's being connected to through some proxies if necessary. So what exactly is Killsuit? I've given you an overview of DanderSpritz and a few of the different things about it. Well, first of all, I got to tease you a little. Killsuit is not specific to DanderSpritz. It can actually be plugged into quite a few of the equation group's post-exploitation toolkits. In the month after the Lost in Translation leak, the ShadowBrokers teased another leak, and they leaked a manual for a toolkit called United Rake. United Rake is just kind of a more scalable, mass-deployed post-exploitation toolkit that's deployed by the equation group that I'll mention a little bit later. And what we see in there, in addition to some screenshots and some explanations of the United Rake functionality, is that Killsuit, which I found interesting because I found it in DanderSpritz, was also mentioned in that tooling. So Killsuit can be deployed not only by DanderSpritz, not only by United Rake, but quite a few of the equation group's tools. All right, so finally, what the heck is Killsuit? Killsuit is actually an extremely modular persistence framework. It actually has quite a few different supported persistence methods. So I call it a framework not only because it can plug in a bunch of different ways to persist on the machine after you've landed on it, but it can also load several different plugins. So you can persist on the machine with a wide range of different plugins, including pedal cheap, that implant that communicates back, and some other tools that we'll cover. Another thing, as you would imagine with the equation group or a very encryption-heavy nation-state actor, everything that has to do with Killsuit that means leaving something persistently on a box is encrypted. Absolutely everything is encrypted. It's chain encrypted. One function like decrypts the next. So it's hard to kind of take a look at it if you don't understand how that works. Some few things about Killsuit, as I'm going through this presentation, you'll hear me say, is an instance. So Killsuit is a persistence framework, but there can be multiple instances of Killsuit running on a box at once that are responsible for orchestrating different persistent implants. A type of Killsuit instance is just a Killsuit instance that's specifically configured to load and persist a complex implant. We'll talk about what some of those implants are in a bit. Killsuit also has this concept of a launcher. A launcher is a driver that actually gets exploited by Killsuit, if necessary, to run kernel mode code to bypass OS protections. So they run the launcher, they wait for the launcher to run, and then they run a bunch of things under that by exploiting the driver. And a Killsuit instance can load several different modules. So perhaps an implant has several different modules. Maybe it has a kernel mode component and a user mode component, or like a watcher. All of those modules are loaded into Killsuit. And finally, they have this concept of a module store, which is just an encrypted virtual file system that resides entirely in registry. First things first, I want to mention in the DanderSpritz toolkit, there's this command available called KISU survey. KISU is just their short name for Killsuit, and the survey capability can actually tell the operator what methods of Killsuit persistence are available to them on this machine based on the operating system and what the safety handlers have determined is actually safe to implant this machine with. The first, as you would imagine, is a driver. And again, this is 2013. We're looking at like Windows 7 32-bit, where forced kernel driver signing was not a thing, so we could load a kernel driver, no problem. However, if we were on Windows 7 64-bit, then we needed some other way to get persistence on this box that wasn't just loading an unsigned kernel driver. And that is SOTI, which stands for SOLARTIME, and I'll mention that in just a second. And then finally, they had another persistence method called Juvie, which stood for just visiting, and it was a Windows XP persistence method. I just got to say, just visiting as a code name for like a persistence technique was fantastic, so I really love that one. All right, so let's talk about what exactly SOLARTIME is. That's that SOTI thing that I mentioned. SOLARTIME is actually a super complex bootkit. It's a bootkit that installs by modifying the VVR, so the volume boot record, of the machine's hard drive. And what it does is it takes control of the boot process right before the initial program load starts. So normal load of a machine is you have the master boot record that tells you what's available to boot from, a volume boot record that gives you a bit more information about the volume that you're booting, and then it jumps into an initial program loader. It takes control of the machine right before that initial program loader, and from then on, SOLARTIME kind of owns everything about how the machine boots. Interestingly enough about SOLARTIME is it is the one piece of tooling that doesn't really reside fully in the registry because it just can't access it yet. So what it does is it uses an encrypted TrueType font file as a container for the kernel driver that it's going to load as the machine is booting. And we'll look at that in just a second. What it does is once it's started the machine booting, it'll wait for winload.exe to load and patch it. So now it's got control of winload.exe. It'll wait for the very first driver to be loaded, the first kernel driver to be loaded, and it'll patch that as well. What it's doing there is it's launching the concept of a kernel mode orchestrator, and I'll talk about what that means in just a sec. So far, we've got a bootkit, and there's a lot of tooling to interact with this bootkit in the DanderSpritz framework. You can see me running a Python script that they called checksoti.py. This specific tool actually looks at the first 8K bytes on the disk and determines if the BBR has been modified, and then also finds that encrypted TrueType font file that stores the kernel driver. So here you can see that DanderSpritz and Killsuit has determined that I'm not using the legitimate TrueType font file stored here, so it's gone ahead and written another one, and this is the kernel driver. So as I mentioned, we now have control of the boot process, and we've loaded a kernel mode orchestrator. The kernel mode orchestrator is responsible for running kernel mode code for any other modules or implants that need to interact with the kernel or need that capability. And it's doing so by, again, hijacking that kernel mode driver that was loaded first. This gives us the ability to run unside kernel mode code and user mode code at once. So we can run either user mode code or kernel mode code depending on what the implant needs. It then begins launching a bunch of implants and modules that it was configured to launch. And it'll actually inject the malicious implants into user mode code if necessary. So a lot of their tooling actually injects into LSASS or other processes when they only need user mode code execution. Interesting bit about SOLARTIME and Killsuit. Kaspersky in 2015 released a report about the equation group and some of their tooling. And in this report, they actually called out this tool called Greyfish, which at the time they mentioned was a fully functional post-exploitation toolkit. What we know now is that Greyfish was actually just the SOLARTIME persistence method that exists within Killsuit. And then everything else above that is completely customizable by the operator and by the DanderSpritz tooling that's kind of wrapped around it. So let's talk a little bit about defense evasion, or what these guys are doing to kind of hide from the good guys or hide from the defenders. Well, the first thing that I mentioned is that literally everything that Killsuit drops on disk or in registry is encrypted with a unique key per target. Sometimes it's the unique NTFS ID of like a specific folder on the drive. Sometimes it's like the actual serial number of the hard drive that's being iterated over thousands of times to generate a key that will decrypt some of these stages. The entire virtual file system is stored in registry, and there's different portions of Killsuit that are responsible for decrypting different portions of this virtual file system. And if we ever need to create files, it's going to be temporary. We're going to clean up after ourselves, but we're also going to do some time stomping to make it difficult for the IR team to identify files that we've written or modified. So the framework will automatically do things like look for user.exe, which would tell us around the time that Windows was installed, and let's match all of our files that we're dropping with those timestamps. One of the coolest capabilities of this framework is if you're the equation group, you apparently have enough time and bandwidth to have a team develop your own custom TCP/IP stack for you. You know, using the Windows APIs is for plebs. So what they've done is they've literally coded their own custom TCP/IP stack to avoid touching WinSock, right? We don't want to use the WinSock APIs because that makes it easy for some people to discover what the machine is doing. So they carry in their own custom TCP/IP stack, which prevents us as defenders from running something like Netstat or Wireshark or other traffic analysis tools locally on the box and seeing their covert communication. They have two versions of this TCP/IP stack. One is called FluAvenue, and that supports IPv4. They also have IPv6 support because they were clearly forward-leaning. With FluAvenue tooling, you can actually see me here running a command which is called FluAvenue control. It lets me do things like ipconfig, configure adapters to use IP addresses, and just kind of gives me access to raw sockets. Again, bypassing the WinSock API. They actually use this raw sockets access to do a lot of interesting things. So once they've gained persistence on a machine and have decided to use it as a beachhead to kind of pivot internally within an organization, they have a command that they use called redirect, which can establish like a VPN-like tunnel on this machine and let them tunnel between this and several other networks. Interesting thing, that fuzzbunch post-exploitation toolkit the exploitation toolkit that I mentioned that comes with Eternal Blue, it can be configured to use a redirector. So you can give it the IP of a FluAvenue implanted machine and say, hey, redirect through this machine to my actual target and exploit that. Several of their other tools can do the same thing. They also use this custom TCP/IP stack to kind of hide their implants in interesting ways. They actually allow port knocking, which I didn't expect from a nation-state adversary. But with this capability, because they're listening on raw sockets, they can do things like, hey, look for a packet that's going to this port with this TCP sequence number. And then expect another packet with this window size. And then they can chain up to 5 of these different packets, which is considered a knock, which would then trigger a callback to the listening post, or open a port that Pedal Cheap is listening on. Other cool things that this toolkit can do is enable the equation group and their operators to do a bunch of data gathering. So nation-state malware guys, they're not looking to just deploy a bunch of coin miners or drop adware on our machines. Their goal is to get as much information about this organization or what the machine has been implanted on as possible. So, of course, they have keyloggers. In fact, they have 3 of them. I don't know why they have 3 of them, but they have 3 of them. And each of these keyloggers, called STRANGELAND, YAK, and GROK, can be installed via Killsuit as a persistence method. And then, as you would expect, all of these specific keyloggers can store data in configurable encrypted paths. Here you can see the capabilities are pretty standard from what you would see on a keylogger. But you can see that when I typed this is my super secret password into notepad.exe, that I had no LED keys lit on my keyboard, and that I typed it into Notepad. One of the coolest things about this, though, is that the tool that decrypts the keystrokes has kind of translators between different languages. So when you actually decrypt the keystrokes, it'll give you an ASCII version, an English version, perhaps Arabic or Russian, and try to translate that for you, just in case you don't happen to natively speak the language that the machine is being used. It also comes with a tool called DARKSKYLINE. And DARKSKYLINE is a fully featured packet capture tool. It can ride on the raw sockets capability and kind of raw network access capability that FluAvenue provides, and uses Berkeley packet filter. So any of you who have used Wireshark or TCP dump, building filters for traffic that's interesting for the operator is super easy. And we actually capture all of that encrypted data to, as you would expect, an encrypted container with a unique key per target. Here you can see that the equation group really loves using TrueType font files to store encrypted data. So if you're ever on the hunt, look for TrueType font files. Few cool things about the kind of different filters that come pre-built with DARKSKYLINE. So DARKSKYLINE gives them a bunch of different pre-built filters, which includes like Cisco Discovery Protocol. If you're sitting on a machine, be it a router or a machine that actually has access to some Cisco networking gear, you get a lot of awesome information from Cisco Discovery Protocol, including like names of the switches, VLANs that are available, a bunch of interesting things. Another thing that I thought was hilarious was they actually found Conflicker on that Middle Eastern Swift operation all over the place. So in their operational notes, you'll actually see, hey, this machine has Conflicker, this machine has Conflicker, this machine has Conflicker. And in certain scenarios, they went and cleaned up Conflicker for the organization because it made their life easier. They also have filters for MS SQL logins and queries, which is super useful, right, to an operational team that's looking for data that's of importance. It may be in a database. So they have a filter that can look for all of that. Speaking of databases and interacting with them, there's actually a bunch of different SQL database reconnaissance tools in DanderSpritz that can be installed persistently using Killsuit. They can actually load drivers kind of in memory temporarily to interact with a bunch of different database platforms, kind of like, you know, ODBC drivers. But they have support for MS SQL, MySQL, SQLite, and Oracle. So if they don't land on a machine that has this support natively, they just kind of bring it in with them. Another cool thing is for Oracle, they have they had, I guess, an authentication bypass that they called Pass Freely, where if you ran across an Oracle database, it just prompts you, hey, do you want to pass freely? And you just kind of bypass the authentication for Oracle. They did that for a bunch of different database solutions. You can see that they have query plans that lets them query different types of databases, like those for Kaspersky 6, Kaspersky 8, SolarWinds, and WSUS were interesting, as well as SharePoint. So they had kind of, if they got direct access to the SharePoint servers, they can just do SQL queries to find documents or data of interest to exfiltrate. Also, WSUS was super useful because I, as a previous blue teamer, wanted WSUS talking to all my machines and then patching them. Well, the equation group did too, because you can really map out an entire network using WSUS data. Other cool things that they're carrying in via this persistence method is Wi-Fi man-in-the-middle capabilities. They have a tool called Magic Bean, which is responsible for doing full Wi-Fi man-in-the-middle. So if you look at some of the WPS attacks that were talked about in 2017, some of those capabilities actually exist in these tools from 2013. It actually uses its own Killsuit type instance, which tells us that it's probably a bit more complex than other things that need persistence. And if necessary, like if you want to do deauth or other things, it can install Wi-Fi drivers that have packet injection capabilities if the card supports it. So if I actually need to inject packets into some kind of Wi-Fi channel, they can bring in those drivers. Here you can see me installing installing with KISU install the type MABE. And there's a bunch of different types that can be installed with Killsuit, and we'll talk about that later. They also do a bunch of stealthy exfiltration, right? So their goal is get in, find data, get out without being noticed. And that means that you probably need to develop your own custom network protocol. So not only are they developing their own TCP/IP stack, they're rolling their own custom network protocol so that if you have some sort of network monitoring capability, you're not going to catch them. There's two kind of different functions within this custom network protocol. There's STRAITBIZARRE, which is an implant that's actually designed to stealthily exfil a bunch of data using the network protocol that they call FRIEZERAMP. FRIEZERAMP is their custom network protocol, and as you would imagine, it's all fully encrypted and stands up unique different sessions per machine. It also provides adapters to insert packets into the transport layer protocols. So let's say you're in a kind of environment where they're doing deep packet inspection of TCP, UDP, ICMP, whatever, they have adapters that can make their network traffic look like those protocols so that they're allowed outbound by any proxies or anything else that's doing deep packet inspection. And then this actual network protocol is super similar to IPSEC. So anybody who has seen IPSEC in action and understand how IPC works will see that IPSEC is extremely similar to FRIEZERAMP. Here you can see me running a command called FRZ links, which shows us all the links that have this FRIEZERAMP capability enabled, kind of have the capability to send FRIEZERAMP traffic. You can also list security associations. So very similar to IPSEC, what are the security associations? What are the key exchanges that have occurred that allows us to route through these different tunnels that are stood up? And you can see that we have quite a few different addresses. Here in this case, the one route that we have is the route to the listening post. So when DanderSpritz starts up, it always has this FRIEZERAMP IP address, or I guess network address, of Z001/32, and then all the other targets are 02, 03, 04 sequentially. That's kind of how they configure their FRIEZERAMP addressing. If you're interested in learning more about FRIEZERAMP and how it works as a network protocol, the team at ForcePoint did a fantastic kind of in-depth white paper into this. They titled it like pedal cheap network traffic. So if you're interested in how this network protocol works, I would really recommend looking at that. Other things that we have is SOMBERKNAVE. SOMBERKNAVE is a capability that seems to be used most often when machines are air-gapped, but poorly. So if you have a machine that's connected to a physical Ethernet network that's air-gapped, but it has a Wi-Fi card on board the machine that may or may not be enabled, SOMBERKNAVE can actually enable that Wi-Fi card, carry in drivers, and then exfil data that way. You can actually use the credentials or other data that you've gathered using that magic bean Wi-Fi man in the middle tool to authenticate to a Wi-Fi network that may be accessible, or if there's an open Wi-Fi network nearby, it can piggyback on the open Wi-Fi network and exfil data that way. And that's also a Killsuit instance that can be installed. So if you run the command KISU install type SOKN, which is just their short name for SOMBERKNAVE, you'll see this capability installed on the target that you are implanting. So we've talked about all these cool capabilities that Killsuit has, but I also wanted to mention that they have this other concept of a quantum shooter. So if you recall, I talked a little bit about STRAITBIZARRE, which is an implant designed to use the stealthy network protocol FRIEZERAMP for data exfil. It actually has another capability. It can be configured as a STRAITBIZARRE or quantum shooter. And I'll talk about what that means now. So let's say that you're a very well-funded nation-state adversary that happens to tap about 80% of global network traffic. How do you use that to your advantage as an adversary? Let's say that you were going after a hard-to-reach target where maybe just going through their perimeter is not an option, or maybe it's too noisy. What you could do, theoretically, is identify interesting targets within the network and then tag them and say, hey, this target uses this Yahoo email address, or this is their current Facebook cookie, or here's some other interesting bit of information that's unique to this target. And if you have this global surveillance network that's monitoring a ton of internet traffic, you can actually send your team a tip-off to say, hey, that dude you asked me to watch for, that Francisco guy, I just saw him connect to some server. What do you want me to do about it? Maybe your infrastructure then gets this tip-off and configures a task to communicate to a quantum shooter, that STRAITBIZARRE implant, that's geographically close to your target, and say, hey, here's some TCP information, calculate the TCP sequence number that would be in this TCP sequence thus far, and actually inject a man-on-the-side packet. So beat the response from the actual server back to the target, and redirect the target to an exploit kit server. They redirect targets to an exploit kit server. This exploit kit server is called FoxAcid. So if you've seen an exploit kit like Black Hole or other exploit kits, very similar, except this is full of ODay. Based on what I saw, it looks like they had ODays for Internet Explorer, Safari on iOS, and all other tools that could exploit anything that a user might be using to browse. So now we have kind of targeted exploitation at scale. How do they make sure that Joe over there doesn't get implanted with nation-state malware accidentally? So they have this STRAITBIZARRE shooter that I mentioned earlier, but they also have a piece of code that they call a validator. The STRAITBIZARRE shooter has injected some network traffic that's redirected us to a malicious server. That malicious server is delivering an exploit which implants us with this validator. The validator is responsible for validating that the target is of interest. So this is actually this network admin at the company you're trying to compromise. Here's the financial guy, whoever it may be. The validator does that confirmation with a config file that's passed by the server, and then you get upgraded to United Rake. So if you remember that United Rake framework and that manual that was leaked, it's kind of their mass CNC system that just calls back to United Rake as a server any time of implant or a target of interest has been implanted. These specific United Rake systems can then be upgraded to DanderSpritz and implanted with Killsuit if they need to do more complex things. So let me tell you a quick story about how I ended up looking at Killsuit specifically. So Casey Smith on Twitter, his handle is subT, and I happen to live close to each other, and he's a good buddy. We were one day on I don't remember, a Saturday, we were scratching our heads trying to understand how SOLARTIME worked. You know, none of us are really bootkit people, but we're reading, trying to understand how the heck this Killsuit thing works. When we noticed that this SOLARTIME thing works, when we noticed that when we actually installed this persistent bootkit, it ran a command on DanderSpritz called KISU install type PC. We're like, what the hell is that command? So we feel kind of dumb, haven't figured out how this bootkit works, so we start digging into how this works. And what we can see that when we run a command that tells us, hey, give me all the list of KISU instances on this box, it listed this Killsuit ID, some hex thing with PC next to it. We end up talking for a while, and I remember that in some of the decompiled bytecode that was in the leak, because all the Python was bytecode compiled, there was no source code, but getting bytecode Python to Python is fairly easy, so I did that. And I saw this list, this random list that they called IDs in one of the Killsuit folders. And I realized, hey, that PC thing that I saw, there's an ID next to it. And we did a conversion where hey, holy heck, that hex ID was this integer that existed in this file. So we saw all these other types, so we just sort of went crazy. We're like, hey, KISU install moan. No idea what the hell moan is, but I'm going to install it. And we installed every single one of these types and just started okay, what does this do? I have no idea. So, all right, so we're caffeinated. We're still digging around. And I'm reading through that check SOTI script, which checks what version of SOLARTIME is installed on the machine and which TrueType font file has been used as the container. And as I'm reading through this Python, the code's super helpful, and it says, hey, if you don't know what version of SOLARTIME is installed, double feature will confirm. So we're like, all right, the heck is double feature? It's going to confirm, so it's got to be interesting. So we run this double feature command, and lo and behold, super helpfully for us, it starts dumping a bunch of information about how Killsuit and this instance is configured. So it gives us the instance ID. It's like, hey, this is the location in registry where the kernel mode orchestrator is installed. Here's the location where the userland thing is installed. And this is where it's encrypted. Here's the encryption key. Double feature, super helpful. So what do we start doing, right? We're like, hell yeah, we're going to install every type and use the hell out of double feature. We're going to use double feature to figure out how this stuff works. So we launched double feature, as I mentioned. And you can just literally click a button. It's like run a standard double feature query. It'll load some code, a DLL into memory, collect a bunch of information, send it encrypted back to the LP, and that listening post will decrypt it. So there's a decryption utility and kind of a report parser that exists within the double feature folder in the DanderSpritz leak. And we saw, hey, we can actually run double feature and figure out how all these tools work. Interesting thing about double feature, it also seems to have capabilities to actually debug that United Rake framework that I mentioned. So you can use double feature to put United Rake into debug mode. Super useful for an operator, even more useful for us as we're looking at what the heck this thing does. All right, so I talked about that IDs file having a ton of different IDs that were listed on it. And we're like just installing all of these to try and figure out how they work. So as I click through this, you'll see that the ones that I've underlined are the ones that we've understood and kind of have taken apart to see what they do. There's a bunch of them. Personally, Wraithwatch is super interesting. If you're bored one night, start using LinkedIn and search for Wraithwatch, and you'll see a bunch of people who have completed Wraithwatch training. Those people have awful OffSec. Like, that is terrible. But we have a ton of different things. Double Dare, Magic Grain, Magic Monkey, Sleepy Sheriff, Snuffle Unicorn. Who the heck is coming up with these names? Woozy Ramble, SOMBERKNAVE, and Strangeland. OK, so we have all of these. Everything in this slide is stuff that exists as implants that can be installed by Killsuit. Everything underlined is what we've researched and what I've researched so far. So my call and my ask of you guys is those of you who are interested, please help us figure out what Wraithwatch is or Snuffle Unicorn. I'd love to read about it. And in order to enable you to do research, I actually put together a DanderSpritz lab. My DanderSpritz lab project will fully configure a fully functional DanderSpritz tool in 2 commands. You use Packer to build it and Vagrant up to run it. So in those 2 commands, you'll have a fully functional DanderSpritz lab, which includes the DanderSpritz listening post, which is a pain in the ass to configure. It needs like an old version of Python and like WinPy32 from years ago, but you have it there. It also includes a target, so the machine, it's a 32-bit Windows machine, and a domain controller. On that domain controller, I've installed a bunch of policies that push down like Windows event forwarding capabilities, WMI, listeners, and like all sorts of different things that as a blue teamer, I use to detect bad stuff. But when I was doing this research, I used to figure out how it worked. So please look at DanderSpritz Lab, look at DanderSpritz. There's a ton of research to do. It took them 15 years to build these capabilities, and we've only had it for 2. And nobody's really looking into it. So would love to have you guys help me with this research. And that's what I got. Oh, yeah, I also own DanderSpritz.com. So if you want to go to that website, I've documented a lot of this. Cool. Guess it's time for questions. Don't be shy. I don't think anyone's going to kill you. Cool.
All right, thank you very much for the prezo.
Thank you.